Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to discuss about a topic from automatic generation control. The name of the topic is generator load model. So let's start with a derivation. Now, under a steady state operating condition, the synchronous angular frequency is given by. So I will write it here, steady state operating condition. What is the meaning of steady state operating condition? The meaning is nothing but here the load is not going to change. The load is constant. So what is the value of a synchronous angular frequency? So I will write it here. This omega s will be equal to 2 pi into fs. We know this is a simple formula where this omega s is nothing but what? It is your synchronous angular frequency. On the other hand, here if you see this fs is nothing but synchronous frequency, or in other words we can say that it is a rated frequency. Now let us assume that due to increased in the load demand, so I will write it here, let delta PD is equal to change in a load demand. This is what? Change in the load demand. D stands for demand, P is the power, so we can say it is demanded power. Demanded power is nothing but what? Power which is demanded by the load, so we can say it is a load demand. This delta represents it is change in the load demand. Basically when we talked about change in the load demand, then we are talking about increase in the load, because we know that in the power system it is assumed that the load is continuously increasing. So let us assume that due to increase in the load demand delta PD on the generator, there will be increase in the corresponding value of angular position of a generator. So let's say if your demand is increased by amount delta PD, then in that case what is the change in the rotor angle? So I will write it here, change in the rotor angle will be by how much amount there will be change in the load demand, by that much amount there will be change in the demanded we can say load angle. So when we take delta PD, then we have to consider here delta. So what is this delta? I can write it here. This delta, it is nothing but what? It is corresponding change in angular position. Corresponding change in the angular position with respect to change in the load demand, that is with respect to change in the power demanded. So how we can write a new operating angle? So I can write it here. Let's say our new operating angle will be, so new operating angle, I will represent this as a delta which will be equal to delta 0 plus delta. It is in radian. So consider this as a equation number 2. Now what is this? This delta is nothing but it is new operating angle. Delta 0 is nothing but it is initial load angle. What is the meaning of initial load angle? Whenever your system is at a steady state operating condition, and whatever will be the change in the load angle delta, that change in the load angle delta due to change in the load demand, it is represented by delta. Now we know that change in the rotor angle is caused due to increase in the speed from its rated value. So therefore I know what is the relationship between omega and the delta. Omega will be equal to what? It is equal to d delta by dt. We can read this as rate of change of load angle delta with respect to time is nothing but a speed. So let us take this is nothing but your equation number 3. Now if you compare this equation number 2 and equation number 3, how I can write? So I will write it here, from equation number 2 and equation number 3, how I can write? This omega will be equal to what? D by dt of delta. So it is nothing but what? D by dt of your delta 0 plus delta. Just what I did, in place of this delta I just substituted this term. Okay, so d by dt delta 0 plus delta. So how I can write this equation further? I can write it as omega will be equal to d by dt of delta 0 plus d by dt of del delta. So treat this equation, we can take this equation as what, or otherwise I'll write it first, another step here. Omega will be equal to what? Omega s plus d by dt of delta delta. Take this as a equation number 4. So you'll ask me, sir, why here we have written d delta 0 upon dt equal to omega s? Because what is this? This is your initial load angle. And what is the speed at initial, we can say initial operating condition? It is nothing but synchronous speed. So d delta 0 upon dt will be treated as omega s. So how I can write? That is, I can write this as omega will be equal to omega s. We know what is d delta by dt, it is omega, and as here delta is there, so I will write it here delta. So this is your equation number 5. The unit for this is nothing but rad per second. Now we can write from the above equation one thing. This omega will be equal to what? 2 pi f. Omega s will be equal to 2 pi fs plus this will be 2 pi into delta f. So if I remove 2 pi from both sides, then I will get the equation, I write it here as f will be equal to fs plus delta f. Treat this as a equation number 6. Where what is the value of delta f here? So let's see, I'll write it here. Please see this part. This, then this and this. We know that d by dt of del delta will be equal to delta omega will be equal to 2 pi into delta f. So therefore, from this expression, can I write like this? Delta f will be equal to 1 upon 2 pi into d by dt of del delta. Yes, what just I did? I have taken this term to this side. So delta f will be equal to what? 1 upon 2 pi d by dt del delta. Consider this as a equation number 7. Now here we are talking about a generator load model, means basically we want to have an expression in terms of a power. So before that I have to take an expression for a kinetic energy stored, and from that expression of kinetic energy only we will be able to find it out what is the equation of a power. So let us see the kinetic energy which is stored in the machine is nothing but, already in unit number 1 we have seen this formula. Kinetic energy we will represent this as a W, which is equal to half into J into omega square, where this J is nothing but what? Moment of inertia. Please refer the videos of unit number 1 in a swing equation or dynamics of synchronous machine. We have gone through this concept. So how I can write this? W will be equal to what? 1 by 2. J will be as it is. So I will write omega will be equal to 2 by f. It will be square. Megajoule. Consider this as a equation number 8. Now we have the kinetic energy in the machine at synchronous speed also. This is the kinetic energy stored in the machine. We are not talking about here any synchronous speed, but when we taken into consideration the synchronous speed, then we have to write again the expression. So I will write it here: kinetic energy stored in the machine but at synchronous speed. So for the sake of understanding, now I will differentiate this. Kinetic energy stored in machine, it is represented by W, and this kinetic energy stored in the machine at synchronous speed, it is represented as a Ws. So capital Ws. So this will be 1 by 2 into J into omega s square. Why omega s? Because here we are talking about at a synchronous speed. So how I can modify this expression? Half into J into 2 pi fs square in megajoule. So treat this as a equation number 9 here. Now what I will do? I will divide equation number 8 by equation number 9. So I will get one expression. What I am going to do? Divide this equation number 8 by equation number 9. So W upon Ws will be equal to, if I divide this right hand side, so half J will cancel, 2 pi square will cancel. So we will get F upon Fs total bracket square. So from this expression I can write it as W will be equal to what? Ws into F upon Fs bracket square. Now what is this F? F will be equal to, if you see here we have written equation number 6, F will be equal to what? It is Fs plus delta F. So I will substitute this term here. So what I will get, therefore W will be equal to Ws. F is nothing but what? Fs plus delta F divided by Fs total bracket square. So let's solve this. How I can write it? So I write it here. W will be equal to Ws into bracket. If I separate the denominator, then it will be 1 plus delta F upon Fs total bracket square. Now we know what is the formula of A plus B square. Okay, so I will write it based on that formula. W will be equal to Ws into bracket A square, that is 1, plus 2 into delta F upon Fs, which is equal to what? 2ab, plus B square, that is delta F square upon Fs square. Now we know that what is this delta F? This delta F is a very small. Let's say if we have a frequency of 50 Hertz, then change in the frequency might be 49.8 or let's say 50.2, like that. So it is very small, and this Fs is the 50 standard frequency. And if you see here again the square term is there. So let's say suppose change in the frequency is 0.1 let's take 0.1. So 0.1 square divided by this 50 square. So you will get the answer, but which is very small, something like 0.000 something will be there. So it is nearly equal to 0. So what we will do, as this term is very small, so I will neglect this term. I will neglect this term. So neglecting this square term, what I will get? W will be equal to Ws into bracket 1 plus 2 delta F upon Fs. So mark this as the next equation. I think we have previously taken equation number 10. Okay, I have not given equation number 10 here. So I will give equation number 10 to this expression. This expression, it will be equation number 10, and here this will be equation number 11. Now we know, as I discussed earlier, we have to find it out. Generator load model means basically we need to think about a power. So already here we think about energy. So we know how to find it out, power from the energy. So let the increase, I will write it here, let the increase in the power, increased in the power is nothing but what? It is nothing but rate of change of energy. To be precise, rate of change of kinetic energy here. So how I can write rate of change of mathematically? We can write it as d by dt. So therefore, from this equation 11, I will write it as d by dt of W will be equal to what? Will be equal to d by dt of right hand side term, which is Ws into bracket 1 plus 2 into delta F upon Fs. So let's solve this. Now what is this d by dt of W? I can say this is nothing but your generating power, that is Pg, and as it is rate of change of, so therefore change is represented by a delta. So it is delta Pg will be equal to, now if you take it inside, Ws is nothing but what? It is a constant. So there will not be any derivative, it will be 0. Okay, plus 2 into delta, if you see 2 into this Ws will go inside Ws upon Fs, these are the constant things, and this delta F which will change with respect to a time. So I can write it as it is d by dt of delta F. So consider this as an equation number 12. Now we know already we have discussed this thing in unit number 1. What is inertia constant H? Inertia constant H will be equal to what? Kinetic energy upon MVA. So here we can write it as it is your Ws upon G. This will be your equation number 13. What is this? The inertia constant is defined as kinetic energy stored in the rotor per MVA capacity of the machine, where this G is nothing but 1 per unit. Let's say this will be a 1 per unit. So if I substitute this term in equation number 12, so what I will get? I write it as d by dt of W which is same as that of your delta Pg, which is equal to what? Here in place of Ws upon G, now G is 1. So in place of Ws, what I can write here? H. So my expression will be 2H. This Fs will as it is, and here I write it as d by dt of delta F. Now it will be in per unit because here it is divided by MVA. So let's take this will be your equation number 14. Now we know that as the frequency changes, the motor load changes being sensitive to the speed. The rate of change of load with respect to frequency is given by. So I will write it here. Rate of change of load with respect to frequency. So change in this parameter with respect to this. What is the meaning of this? Daba PD upon daba F is nothing but what? I can write it here. It is rate of change of delta PD is nothing but you can say it is a load demand. Load demand with respect to frequency. Or we can say change in the power demand due to change in the frequency. Change in the power demand due to change in the frequency. So therefore, let the change in the load demand is denoted by. So I will write it here. This is daba PD upon daba F is equal to capital D. This capital D, it is nothing but what? It is nothing but your load damping factor. This will be a load damping factor. I'll treat this as a equation number 15. Now the change in the load demand, so from this can I write like this? Daba PD will be equal to change in load demand will be equal to D into daba F. Yes, I can write it like this. Or in other words, I can say instead of daba, can I write like this? Delta PD will be equal to D into delta F. It will be what? It will be per unit, and megawatt will be there because we are talking about demanded power. So therefore, for all the type of loads, it experiences the change in the power consumption with respect to frequency. So let's see, now we have this delta Pg, which is nothing but what? Change in the power generated. Now what I will do, I will write it here. There is a power balance equation. So I will write it here. We know the power balance equation. What is the meaning of power balance equation? How much demand will be there, at least that much amount of generation has to be there. So delta Pg equal to delta PD, or I can write it as delta Pg minus delta PD will be equal to 0. Now what is this delta PD? Now I will write it here from this expression. I will write it here. Delta PD will be equal to minus D into delta F. Now you will ask me, sir, why you have taken this minus sign? Why you have taken this minus sign? So I will explain this here. Minus delta F. Okay. Or instead of this minus, let me write it here plus only. Delta PD equal to plus D into delta F. So if I substitute all the values in this formula, what is delta Pg? I got this 2H upon Fs d by dt delta F. So I will write it here. This power balance equation is what? Delta Pg minus delta PD will be equal to, this delta Pg is what? 2H upon Fs d by dt of delta F. Minus sign will be as it is, and PD will be equal to what? Delta PD will be equal to what? Plus D into delta F. So I will write it as this. But now again, if you see, delta PD will be equal to, I have written plus D delta F. Basically it is not a plus, it is what? Delta PD will be equal to minus D into delta F. Now the question is, why it is minus D into delta F? What is the reason here? The simple reason is nothing but by how much amount your load will increase, that much amount your frequency will decrease. That is, the relationship between load and the frequency is inverse. So that's why here the sign is nothing but a negative. So if it is a negative, then delta PD equal to minus D delta F. So if you substitute here, then here you will get this minus, it becomes plus. I think you understood here why we have taken minus sign. The simple reason is what? As the load increases, there will be decrease in the frequency, or we can say there will be change in the frequency. The change in the frequency will be what? It is in a opposite direction. So now whatever equation here we have written, I will take a Laplace transform of this equation. Now why we are taking Laplace transform? Because anyway we have to create a block diagram with the help of this. So this is our transfer function with the help of this. So delta Pg of S minus delta Pd of S equal to this 2h. If you see this 2h upon Fs constant. Here how you can write? Delta f of S, and this is derivative. So therefore we know that Laplace transform of derivative is nothing but what? S into that function. So into S plus d into delta f of S. So we got this equation by using a Laplace transform. Now what I will do, from the right hand side I am going to take here delta f of S common. Delta f of S common. So here you will get it as a d plus 2h upon Fs into S. I think you understood this. What I did here, I have taken delta f of S from right hand side common, this delta f of S. So therefore now can I write like this? Therefore the change in the frequency will be equal to what? I am going to shift this term towards left hand side. So what I will get? I will get it like this: delta Pg of S minus delta Pd of S whole divided by d plus 2h upon Fs into S. So I'll get this equation for what? Equation for delta f of S. So therefore now I'll write it like this, because in any fashion we can write it like this. We will write it as delta Pg of S minus delta Pd of S into 1 upon d plus 2h Fs into S. So I just have written the denominator in another fashion. Now what I will do, to this denominator which is there, I will divide by a d. So what I will get? I will get it like this: delta Pg of S minus delta Pd of S. So you can write it as multiply and divided by d. So how you can write it? I write it like this: it is 1 upon d, okay, whole divided by 1 plus, because we are going to divide this term, specifically this term, or anyway you can consider total term also. We are going to divide by d to numerator and denominator. So I will write it here: divide by load damping factor d to numerator and denominator. So here I will get 1 by d. Here I will get 1 plus 2h upon d into Fs into S. I think you all have understood this, what is to be done. So I will treat this as a equation number 17. Earlier it was equation number I think 16. Have I made this equation number 16? Let me check. Equation number 16, is it there? Yeah, it is there. Delta Pg minus this, we have forgot to write this. This will be your equation number 16. So, and this is your equation number 17. So therefore this is equal to what? This is equal to delta f of S. So therefore I can write or modify this expression as delta f of S will be equal to delta Pg of S minus delta Pd of S into, now I want to take other color. So let me take this other color so that we can write it. So let me take this other color. So this term, whatever this term we have, we are going to take this term as what? It is your Kps upon 1 plus whatever this term is there, this term is treated as it is Tps into S. So let me tell you what is the Kps. So I write it here, where Kps will be equal to 1 upon d. It is called as power system gain. PS stands for power system. So this will be a power system gain. And this TPS, which is equal to what? which is equal to 2h upon d into Fs, which is equal to power system time constant. Now based on this equation, whatever equation here we have, based on this equation, now I can write it like this also, which is equal to what? 2h upon Fs, 1 by d equal to kps. So I can write it like this also. I'll get this relation. TPS will be equal to 2h into kps upon Fs, because this 1 by d is nothing but what? This 1 by d is nothing but your kps. Now based on this above equation, whatever equation we have, I'm trying to draw a phasor diagram, or sorry, not a phasor diagram, I'm trying to draw a block diagram here. So how I will draw this block diagram? I will get it as kps upon 1 plus s into tps. So this will be your, I can say, what is this? This is your power system, we can say transfer function. Now what is to be there here? Delta Pg of S is there, delta Pd of S is there, which will be one is plus, other is minus. So let me write it here. One is plus, so this will be what? This will be your delta Pg of S, which is same as that of your delta Pt of S, that is turbine output power. And this will be positive. And here delta Pd of S will be negative, because in expression it is like this. And what is your output? Output will be delta F of S. So from this expression, this will be your output. This will be, this term is nothing but your gain, and this term is nothing but your input, total term. This input. So from this here we have drawn. So I can write, this is what I'll give the name to this figure. This will be a generator load model. Generator load model, or in other words we can say that this is a power system model also. This is power system model. So if the question is asked, derive or draw the generator load model or power model, and hence derive its expression, how this particular block diagram appears. So we have to write this particular derivation that we have studied. So this is what is about a generator load model. Thank you for watching this video. If you have any doubt, please feel free to ask any questions. Thank you once again.